Hello, my name is Kabira Sinha, and today we will see the problems related to Newton's laws of motion. So how simply we can solve those problems? That seems to be very complicated. Okay, so for that we will have some rules that we know that for downward force there is always mg. So means the force of gravity is always acts downward. So for any body kept on the surface, uh, that downward force is always applicable. Okay, so that is the force. So now we will see that if a block is kept on the surface. Okay, now let us see that this is the surface. This is the surface, and above it a block, suppose a block of 6 kg is resting on the surface. Now we have to tell what are the normal forces on that block. Okay, so from Newton's third law of motion, we simply say that if I apply any force to the, suppose 10 Newton force to the wall, then wall will also apply 10 Newton force on me. So simply we can say that for solving such kind of problem, we will just make a gap so that we can be able to draw all the forces acting on it, and it will be very easier to solve it. Okay, for that we will simply make a gap. So this is our ground, and here is our block of mass 6 kg. Okay, now if that 6 kg will apply any force to the on the uh, surface, means on the surface, then surface will also apply the same kind of force to that block. Okay, in the upward, both will be in the different direction. Okay, so that force is called action and reaction. We call it as normal force also. Okay, so but that normal force is not our motto to find. So we don't take the downward normal force, but for that we can simply say that a block of 6 kg is over here. 6 kg is over here. So here it is normal, and in downward there is a force called mg, and that mg is nothing but mass into g, and we take the value of g as 10. So that 6 into 10, that will be 60 Newton. So for that block kept on the surface of on the surface, so this will have the normal force as 60 Newton. 60 Newton. So that is for one block. Now we will see that what will be the normal force on each blocks if there are number of blocks, or we can say blocks over blocks. So we will see. Now I am making diagram. So I can say that simply suppose this is 1 kg, and above that there is another block that is 2 kg, and that is another block that is suppose 3 kg, or whatever we want we can take. Okay, and these all are kept over the ground. This is the ground. Now we have to tell that what are the forces, what are the normal forces on between each surface. Means what is the normal forces between 1 and 2, then 2 and 3, and then 3 and ground. So there are, what are the normal forces between the contact surfaces. So that is the question always asked in the board examination, as well as especially for JEE students. Okay, so now for that what I have told, that we will make the gap between the blocks so that it will be easier to draw the forces. Now, so for that I am just erasing it, and I will make the gap between the blocks so that we can draw the forces. So this is 1 kg. Now there is gap. Now this is 2 kg and another gap. Then there is 3 kg and then gap, and then this is the ground. So this is the scenario. Now we have to simply calculate the force between 1 kg and 2 kg block, then 2 kg and 3 kg block, and 3 kg and ground. What are the normal forces there? So one force is always applicable over here, and we cannot neglect, that is the love of a mother, that is the gravitational force. Okay? So here always mg force will act. So m into g, that will be 10 Newton, then here 20 Newton, then 30 Newton. So these are the these are always with the any object or any body. Okay, so these are the forces. So 10 Newton, 20 Newton, 30 Newton, all will act according to weight mg, and that will be in the downward direction. Now, for first we will say that if suppose 2 kg will apply N1 force on block 1, then block 1 will also apply N1 force on block 2. Okay, I have told that equal and opposite forces will act. So if 1 kg is applying N1 force to 2 kg, then 2 kg will also apply N1 force to 1 kg. That is it. So simple is it. Now, second we will say that 2 kg is over here. So 2 kg and 3 kg. So if suppose 2 kg is applying, 3 kg is applying N2 force, then on 3 kg N2 force will be also there. Okay, N2 over here and N2 over here. Okay, so I will just change the ink so that it will be easier to understand. Now the third is that suppose on 3 kg the ground will apply the force N3, then 3 kg will also apply the force N3 in the downward direction. So that is the free body diagram of this scenario. Now let us simply see how we will solve. Now it will become very easier to solve it. Okay, very easy. Now simply we can say that N1 is equals to 10 Newton. Okay, N1 is 10 Newton. Okay. Now in the second case we can see that N2 is equals to N1 plus 20. Means the forces are balanced. So upward force will be equals to downward force, and left force is equal to right force. So that is called balanced. Okay. Now, so we can simply say that from here we can write N2 will be equals to that N1 plus 20. That is N1 plus 20. Now, the third equation we can write over here that N3 will be equals to N1 plus 20. N3 will be equals to N2 plus 30. Now we know the value of N1, so we can simply tell that N2 will be equals to 10 plus 20, that is 30 Newton, and N3 will be equals to, N2 is 30 Newton, so 30 plus 30 is 60 Newton. So that is our so simple and means it is a kind of basic problems that is always asked.